All right, so now we're going to use Newton's method. So when we have a function and the root cannot algebraically be found, what we're going to do, Newton came up with this method, is we're going to pick an x1 that is close to where the root is. So the root's right here, right? Okay, root is where it crosses the x-axis. So then what we do is at that x1 value, we draw a tangent line. And the tangent line has a root. The tangent line where it crosses the x-axis is closer to the actual root of the function than when I first began. So that's x sub 2. Then Newton said do it again. So at x sub 2, at that x value right there, we're going to draw another tangent line. So we're going to draw a tangent line here, and the root of that tangent line will be closer to the root of the actual root of the function. So it's the roots of the tangent lines that we'll be finding. So algebraically, this can be shown that x sub 2 is equal to x sub 1 minus f of x sub 1 divided by f prime of x sub 1. This comes from the equation of the line. So this is the formula that you're going to want to identify to find the next x value. So the great news is that your calculator will do this for you. So under y1, you'll want to enter the function, and under y2, you'll want to enter the derivative. So you're going to have to find the store button. The store button is right above your on button. And let's go and do an example so I can lead you through it. All right, so first we want to find the, put in the function. We're going to use this as our x sub 1, and we're going to find x sub 3. So start off by putting in y sub 1 as x squared minus 2, y2 as 2x. All right. So you've got that. y1 is x squared minus 2. y2 is the derivative, which is just 2x. Okay, so now we're going to store an initial value. So this tells us what x value to use initially. So you enter 1. So you get out of the graph mode, exit out of there, get to your home screen, hit 1, and then the store button, which is above the on button, and then x, where you usually hit X when you're entering in functions. Then hit enter. So the calculator in the home screen will say 1. Okay, got 1 in there. All right, this is what you'll end up doing. So you'll say X subtract. Now to get this Y1, to get the Y1, what you want to do is you want to hit vars, V-A-R-S, and then you'll want to hit the right arrow to get to Y vars. The right arrow to get to y vars, hit enter, and then you'll see y1. So you'll hit enter to pick up y1. Then you'll hit the divide by sign. Now we'll want to get to y2. So to do y2, you'll do the same thing. Go to vars, y vars, hit the arrow to get down to y2 and hit enter. Then you want to hit the store button and then the variable x again. So when you do that, the first answer that you're going to get for your x sub 2, your first answer for your x sub 2 will be, let me write it up here, x sub 2 will be 1.5. So that's the first place that the tangent line has a root. The way you've set up with this store x, it's ready to go again. So if you hit enter again right away, you'll get the x sub 3, which is 1.416 repeating. So the way you've got it set up, it will keep doing it for you. So that is your x sub 3, and that's what they're asking you to find in this problem. So what you've actually done is you found an approximation for square root of 2. So x squared minus 2. This would be the positive square root of 2. So you've used Newton's method to find the square root of 2. All right, so let's go and do the same kind of thing to find Newton's method to find the square root of 5. All right, so thinking about what we just did, so we want to have the function be y I'm sorry, not y2, y squared, y equaling x squared minus 5, so that when I set it equal to 0, I get x is equal to square root of 5. So that's what I'm thinking, just like before, when I had y equal x squared minus 2, set that equal to 0, that will give me x equal plus or minus root 2. So I'm wanting to find x equal square root of 5. That's how I came up with this function. So it takes a little bit of thought. You're up to it. All right, so then I'm going to let my y1 equal x squared minus 5, my y2 be the derivative, which is just 2x. So then if I look at the graph of y equal x squared minus 5, it looks like this we can start with x equal 2. Looks like the square root of 5 would be close to 2. It would be a little bit bigger than 2, right? But it would be close to 2. So let's start with x equal 2. It does say that we get to just go up to 6 decimal places. It doesn't tell us where to start, so you have to pick something. And you could pick something different, but you should pick this, something like this. You could choose something different, it has to be close. But if I start with x equal 2, then again, remember the formula, x minus y1, get this by going to the vars button, and then divide through y2, get the vars button as well, store it back in for x. All right, when I did that, I got my first calculation from the calculator of x sub 2 is 2.25. So I want to go till there's 6 decimal places that are not changing. So I hit enter again, and I get 2.23, oops, let me write that again, sorry. 2.236111. And let's do it again. So just keep hitting enter. 2.236067978. And then if I hit it one more time, I get 2.2360777. All right. So if I'm looking for 6 decimal place accuracy, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. These first 6 decimal places have not changed. So to find the root to 6 decimal places, the root would be 2.236067. All right. So let's do the same thing with this one. Number 3. So this is the function. So this is what you would put in for y1. 2x cubed plus x squared minus x plus 1. So remember, y2 is the derivative. So compute that. So 6x squared plus 2x minus 1 is the derivative. That's the y2. Then you'll need to graph this function to find out where you think it crosses the x-axis. So I'm looking at my graph, and it looks like it crosses around -1. So I'm going to say -1 store x. Then I'm going to use this formula you just need to have memorized. X minus y1 divided by y2, store it back in for x. When I do that, I get that x2 is -1.33. I hit enter again, I get x sub 3 is -1.243386,243. I'm writing down more than 6 decimal places just so we can see the numbers. So then x sub 4, I get -1.233855198. So the 6 decimal places are still changing. So let's go to x sub 5. So x sub 5 gives me -1.233751941. So still changing, so I'm waiting to see that the 6 decimal places are not changing. So -1.2337519. Okay, so I see that the 6 decimal places are not changing, so this would be the root to 6 decimal places.